we are back at AP Review. This is 2017 AB Free Response 5. Alright, so two particles move along the x-axis. For the time from 0 to 8 inclusive, the position of particle P at time t is given by xp. xp of t is the natural log of t squared minus 2t plus 10. And so that's the position, right? That's position. And the velocity of particle q is given by vq. So vq of t equals t squared minus 8t plus 15. Particle q is at position x equals 5 at time t equals 0. So it's worth noting that we'll say xq of 0 is 5, right? That's the other piece of information they gave us. Sorry, sliding that over for you. All right. Cool. So for part A, for the window from 0 to 8 inclusive, when is particle P moving left? Okay, so moving left, so the first thing we have to do, we know we're talking about particle P, and they do kind of trick you a little by throwing you information about both, right? So if we want to know when P is moving left, right, that's the ask, right, that's the question. So then let's translate that to what that means mathematically. That means that that if P is moving left, right, it means that the velocity of P, right, V of T, Vp of T rather, is less than 0, right? That's what it means. But for our purposes, that means that we need to find xp prime of t, right, and set it less than 0. So I need to derive. So I'm going to take and find vp of t by deriving this guy. It'll be 1 over the stuff, which is t squared minus 2t plus 10, times the derivative of the stuff, so I'm going to replace that top with a 2t minus 2, right? So in order to find when this thing is negative, I need to first start by finding when this thing is equal to 0, right? So Vp would equal 0 when the top equals 0, right? 2t minus 2 equals 0, which is when t is 1, right? I do also need to pay attention that there aren't any domain restrictions on the bottom. But you can double check. If you want to check and see if something has any real roots, you can do the discriminant, right, which is b squared, right, so 4 minus 4ac, which would be 4 minus a 40. That comes out negative, so there are no real zeros. So this has no real roots, meaning, and it's a smile, right, because it's t squared is positive. So what this means is the denominator is always positive. So if the denominator is always positive, if I wanted to make a VP sign chart, right, starting at 0 with the critical value at 1, and going until 8, we then know the denominator is positive, right? So 2t minus 2 is a line with a positive slope. It's going to be 0 at 1, so it's negative, and then crosses to become positive, right? Below the x-axis, hits 0, becomes positive. And we already know the denominator, right? The denominator is positive based on the logic I put up here. So what that means is that VP is negative and then positive. That's the answer we want. So the interval when this thing is moving left is going to be it is going to include 0. It's moving left at the beginning of the problem until 1, but it's not going to include 1 because it's not actually moving left at 1. Right? At 1, it's not moving at all. It's at rest. Cool. That's part A. Part B, for that same window from 0 to 8, find all times t during which the two particles travel in the same direction. So I'm going to make a note of this work. If I were doing this on paper, I wouldn't have to do this, but because I'm doing it on the board and I'm about to erase the board, I'm going to make a note, right? I'm just going to write off to the side for my own benefit that VP, right, from 0 to 1 was negative, and then until 8 was positive. And I'm going to write that because I need that to talk about which direction this particle is moving when I compare it to the other particle, right? So now let's talk about VQ, right? So I now know which way particle P was moving at what times. So when we talk about B, we need to do the same thing for VQ, right? So I need to know the direction VQ is, or the sign of VQ, so I can know the direction of particle Q. So I need to set this equal to 0, right? I'm going to set VQ equal to 0. I notice that this factors into a t minus 3 and a t minus 5, right? Because I need things that multiply to 15 and add to negative 8. So it turns out that this thing has two roots at 3 and 5. You can either make a detailed sign chart for this, or you can do a visual sign chart because this is a parabola, right? You know that this is a parabola that's a smile because the sign on the coefficient in front of t squared is positive. So what you're essentially looking at, if you go from 0 to 3 to 5 to 8, you're looking at a smile, so your VQ has to look like this, right? So what that means is that VQ is positive from 0 to 3, negative from 3 to 5, and positive from 5 to 8. If you compare this work, right, what you'll realize is that VP, 0, 1, and there's 8, VP was negative up until 1, and then positive for the rest of the time. So if you mix and match to see when they're moving in the same direction, what you're going to find is that they are both positive after 1 for a window, right? They're both positive. And then after 5, they're both positive, right? So the answer is that they are moving in the same direction on the window from 1 to 3 and the window from 5 to 8, and they end moving the same direction, so the 8 would have a bracket, right? So I get 1 to 3 and 5 to 8. All right, and they're both, in both of those windows, they're both moving right. They didn't ask you that, they just wanted to know. So they want you to compare those two sign charts. Part C. Find the acceleration of the particle q at time t equals 2. Is the speed of the particle increasing, decreasing, or neither at t equals 2? All right, so acceleration is the derivative of velocity. So I need to derive VQ. So when I go to do part C, right, if I want AQ of t, I need to derive VQ, right? So that's going to be a 2t minus 8, right? Now they asked me what is the acceleration for q at t equals 2, right? The acceleration at t equals 2 would be a 4 minus 8, which is a negative 4. Okay, so that's the first thing they asked me to do. Then they asked me about whether the speed is increasing, decreasing, or neither. So the colloquial phrase for speed increasing is speeding up. The colloquial phrase for speed decreasing is slowing down. The short answer here is that speeding up happens when velocity and acceleration have the same sign. So it doesn't matter if that sign's positive or negative. Let me give you an example. If I am a bad driver and I'm driving forward, so my velocity is positive, and I see a yellow light and hit the gas, my acceleration is positive because I hit the gas, and my velocity is positive because I'm driving forward, and I am sure enough speeding up as I hurtle myself towards that yellow light, trying to make the light like a maniac. That one's fairly intuitive. Let's go the other direction. I'm in a helicopter. I jump out of the helicopter, no shoot, totally crazy, what's wrong with Hogan? When I jump out of the helicopter, my velocity is definitely negative, and my acceleration due to gravity is the negative 9.804 meters per second squared, so both acceleration and velocity are negative, and I am absolutely speeding up as I plummet to my death. I know there's the whole terminal velocity thing, blah, blah, blah. You get the idea. So, point is, I'm speeding up. So speed is increasing if acceleration and velocity have the same sign. Doesn't matter which sign, just the same sign. The converse of that is that speed is decreasing, or a particle is slowing down, if acceleration and velocity have opposite signs, regardless of which order those opposite signs happen. So the two examples, we'll go back to the car for a sec. I'm driving in a positive direction. My velocity is positive. I'm moving towards a yellow light. I see the yellow light and I hit the brake. So now my velocity is still positive. The car is still moving forward, but my acceleration is now negative because the brake is decelerating me. The positive velocity and negative acceleration mean that I am slowing down as I approach the yellow light like a responsible citizen. Again, that one's fairly intuitive. The one that's less intuitive for people, I'm in the helicopter. I jump out of the helicopter. I'm plummeting. It's terrible. But then I open a parachute. Now, what happens when the parachute opens is I never actually move upward, right? But the drag created by the chute changes my acceleration so that it's not the acceleration due to gravity because I'm slowed down. So my velocity is still negative. I'm always working my way downward. The parachute doesn't magically lift me in the air and make me fly. So my velocity is still negative, but my acceleration becomes positive, and sure enough, I slow down. So knowing that was a really long spiel to tell you that really all you need to do is find VQ of 2, right? And I can find that by doing 4 minus 16 plus 15, right? And I end up getting a 3. And because they have opposite signs, right? So since VQ of 2 is greater than 0 and AQ of 2 is less than 0, the speed is decreasing, right? Again, the colloquial way to say that is to say particles slowing down, but you should use the language they use, right? If they use the language speeding up and slowing down, then by all means use that. If they use speed increasing and speed decreasing, then by all means use that. All right, cool. Part D. Find the position of particle Q the first time it changes direction. Cool. Okay, so they want us to find position, but they want us to find position at a specific time. So if I ask you, where were you the last time you saw your cell phone, the first thing you have to do is think, when did I see my cell phone? Right? So if I ask you, where were you when something happened, or whatever, you have to start by, when did that thing happen? Right? Where were you when you found out that you got into the school of your choice? Well, you'd stop and think, when did that happen? And then you'd think about where. So the same thing is true here. To answer this question, I need the when first, and then I can do the math to find the number they want at that time. So find the position the first time Q changes direction, right? So I need to know when Q changes direction. Well, we've already found the zeros of Q. We did that in a previous, so we already found that not just Q, V sub Q, whatever. We've already found these zeros. We found that it was at T is 3 and T is 5, right? So this is the first time that our particle changes direction. It's not just because V is 0 at these points, it's because we saw that my particle was moving to the right and then moving to the left and then moving to the right, because I had positive, negative, positive velocity. So the answer is at 3. So what they want is they want position xq of 3, right? That's what they want, right? So to do that, I'm going to use the first fundamental theorem of calculus. If I integrate q prime, which is the same as v sub q, right? Sorry, not q prime, x prime of q. I quit, man. There's a lot of letters. If I integrate it from the value I know, which is at 0, to the value I want at 3, I'm going to get x sub q of 3 minus x sub q of 0, which is a value that I know because way back when at the start of the problem it was given to me as 5. So I'm going to integrate my v of t, give myself a little bit of space. So I'm going to integrate my v of t, which was t squared minus 8t plus 15, I think. Yeah, with respect to t, from 0 to 3, and that is going to give me x sub q of 3 minus x sub q of 0, which I know is a 5. So I can add the 5 over, and I get 5 plus t cubed over 3 minus 4t squared plus 15t evaluated from 0 to 3, right? And that's going to give my position, which I call x sub q of 3. Right, so this is a 5. When I plug in, thankfully all the zeros get knocked out, which is something. So I get a 27 over 3, which is 9, right? Minus a 4 times a 9, which is a 36, plus a 45. So I think that these guys net another 9, so I think I get 5 plus 9 plus 9, which should be 23. And that's our winner.